Hello and welcome back to Geology. I want to finish off chapter 14 with floods. And one of the key things about floods, as I mentioned earlier, every river will flood. At some point there'll be flooding. It's just the nature of streams. And the question is, how often do these floods occur? And that's what we're going to call the recurrence interval. So obviously some of the impacts of flooding are erosion of roadways, slumping of landslides, destruction of bridges. A variety of features can occur. Another impact is, remember, when the stream floods, it loses energy and the load that it's carrying is dropped off. So here is an example of this stadium here, covered by fine silt and mud, clay. And here you can see floodwaters raging these homes right in here. So eventually they're going to leave all these deposits, this load that's being dropped off behind. Now let's look at the document camera here. So a flood is a volume of water flowing downstream that exceeds the volume of the stream channel. So the water has to leave its channel. And one of the first things that's going to happen with the floods is there's an energy drop-off. So there's a deposition of load, as we've seen in the photos there. Now, floods, how do they occur? Well, they occur during abrupt heavy rains where the rainfall will exceed the infiltration rate. So in other words, there's no percolation. Or maybe there's a long period of continuous rain, which can lead to floods. If there's a sudden heavy snowmelt in a short duration, and obviously if there's a break in a dam or a levee, can cause flooding. Now, how are we going to evaluate these flood hazards? So I mentioned earlier there's an idea of this recurrence interval. So for a flood of a given size, is defined as the average number of years between successive floods of at least that size. And so we're going to have this formula here, which RI stands for the recurrence interval, and it's going to equal the number of years on record, 10 years, 50 years, 100 years. For many places, especially on the West Coast, we have about maybe 150 years or so, plus 1. And then S is the rank of that flood. So over that time period, was it the highest amount of water, or what was the rank? So was it a really great flood, a really high water, high discharge, or was it a relatively low discharge? And so if we look at the American River, I actually downloaded some data here. So here's some information for the American River. And we're going to look at this 3-day mean. And they've already, based on the numbers here, they've already ranked them for us. So I went ahead and put the ranks here. So the highest 3-day mean was in 1986. That's number 1. That would be and then you can see the discharges get smaller. So remember, CFS is cubic feet per second. And so our job is to figure out how often these floods occur. So for example, let's look at rank number 3 here, rank number 3. So what we'll do, we'll take our formula, the recurrence interval equals the number of years on record plus 1 divided by the rank. So we know that between 1997, which is the most recent number on this chart here, and the oldest number is 1862. So between those two, we have 135 years. So that's how I get the number of years on record. So we have 135 years plus the 1 year, and we're going to do rank 3. And so when we do the math there, when we do this, it'd be 136 divided by 3. So the recurrence interval for this would be about every 45 years. So this would be the 45-year flood. 45-year flood. And then there's another part that your book mentions here called the annual probability. And it's really the inverse of the recurrence interval. And it gives you basically a percent, how often, what's the chance that this flood will occur. So So for this one, on any given year, if we take the annual probability would be 1 over those 45 years, we get 0.02, and then we multiply by 100 to give us percent. So it gives us a 2% probability. The annual probability. So in other words, for that flood, the 45-year flood, it's a 2% chance that it'll occur on any given year. 2% chance that it'll occur on any given year. So anyways, that's what we look for floods. And we really try to chart out their recurrence interval, and we look at these discharge numbers and the peak floods and the ranks, just to try to determine how often these floods occur, really for insurance purposes. If we look at this graph here from your textbook, we're going to compare the discharge, which is basically the flood stage, versus the recurrence interval. And we want to know, we want to try to predict future floods, like the 100-year flood or the 200-year flood. And even though in the lifetime of the historical records of this particular region, we may have not had that 100-year or 200-year flood occur yet, but we can still extrapolate to figure out what discharge would occur. So here is a bunch of data we have for floods that have already occurred, and so we plot this with the discharge showing on the y-axis versus the recurrence interval on the x-axis, and then we can extrapolate this line here. And for example, if we wanted to figure out when this 100-year flood were occur, how much discharge it would have about 650 cubic feet per second. So that would be the discharge for the 100-year flood. All right, well, let's stop here.